In this tutorial, I will be talking about what primary, secondary, tertiary alcohols and amines are, as well as differentiating and explaining the molecule structures and the importance, as well as providing key differences in chemical properties between M-butanol and T-butanol, and the differences, as well as providing sample problems when identifying alcohol amine groups as primary, secondary, or tertiary. Alcohol is an organic compound that has a hydroxyl group in its molecular structure. Each alcohol has an alpha carbon to which the OH group is attached. Alcohol can be classified into three types depending on the number of alkali or alkali groups in which this alpha carbon is bonded. They are called primary, secondary, and tertiary alcohols. The three different types of alcohols can be distinguished using the following principle. The following principle is as follows. Count the number of carbons directly attached to the carbon bonded to the OH. For example, in the first structure, we can see that there's 0 carbons. In the second one, we can see that there's 1 carbon directly attached, which means it is a primary alcohol. The third example demonstrates 2 carbons attached, which means it's a secondary alcohol. And the last structure shows us that there is 3 carbons attached, which demonstrates it is a tertiary alcohol. Moving forward, this chart demonstrates a more in-depth explanation of the molecular structures and their importance. The primary alcohol only has 1 carbon atom bonded to the alpha carbon. So, for example, ethanol, propanol, and butanol. If no carbon atom is bonded, then the primary alcohol is called methanol. So below we have a example structure of a primary alcohol, which is ethanol. This is the molecular structure of ethanol. Next, the secondary alcohol is when 2 carbon atoms are bonded to the alpha carbon. For example, 2-propanol or 2-butanol. Again, below there's a structure that is explaining this, and it is isopropanol, which is considered a secondary alcohol. Lastly, the tertiary alcohol is 3 carbon atoms that are bonded to the alpha carbon. For example, tert-butyl alcohol. So below, again, there is a example structure where we can see that there are 3 carbon atoms bonded to the alpha carbon, which means it is a tertiary alcohol. Next, we have amines. Amines are classified according to the number of carbon atoms bonded directly to the nitrogen atom. This is a principle that is followed. Primary, secondary, and tertiary amines are nitrogens bound to 1, 2, and 3 carbons respectively. So in the first molecular structure, we can see that there's 0 carbons that are being bonded to nitrogen, which means it is considered unique. In the second molecular structure, we can see that there's 1 carbon directly attached, which is considered a primary amine. The third diagram demonstrates 2 carbons, which is considered secondary amine. Lastly, we can see that there's 3 carbons, which is considered tertiary amine. Going into more detail of the molecular structures of each primary, secondary, and tertiary amines. The first one, the primary amines contain 1 alkali or alkali group attached to the nitrogen atom, composed of 1 alkali group bonded to the nitrogen atom. There is no considerable steric hindrance. Below you can see a molecular structure of methylamine, and we can see that there is one alkali group attached to the nitrogen atom, which is why it is considered primary amine. Secondly, we have a secondary amine, contain two alkali or alkali group attached to the nitrogen atom. It is composed of two alkali groups bonded to the nitrogen atom. There is no considerable steric hindrance. This is ethyl methylamine, which is considered a secondary amine because we can see that it contains two alkali groups attached to the nitrogen atom. Lastly, tertiary amines contain three alkali or alkali groups attached to the nitrogen atom. Composed of three alkali groups bonded to the nitrogen atom, this displays steric hindrance. Now, looking at the molecular structure, we can see that trimethylamine displays three alkali groups attached to the nitrogen atom, which is why it is a tertiary amine. Now we will be discussing N-butanol and T-butanol and their chemical properties and how they differentiate from one another. On the left-hand side, we have N-butanol along with its molecular structure. N-butanol is a 4-carbon chain with the OH group on the end carbon. It is used as a solvent and a paint thinner and has some potential to be used as a biofuel. Butyl alcohol is a primary alcohol and is easily oxidized. On the right-hand side, we have T-butanol along with its molecular structure. T-butanol is a 3-carbon chain with an OH group and a methyl group on the middle carbon. Since the alcohol carbon is connected to the 3 other carbons, it is tertiary, hence the prefix tert. It is used as a solvent as well as an octane booster in gasoline and in some paint thinners. Tert-butyl alcohol is a tertiary alcohol and does not react with oxidizing agents. It is useful in organic synthesis in the form of T-butoxide anion, which is generated by the react of tert-butanol with sodium or a strong base, such as sodium hydride, which removes the slightly acidic hydrogen from the OH group, leaving behind a negative charge on oxygen. Now we will be discussing what we have learned so far. Particularly, we'll look at the classification and nomenclature of alcohols. So here I have my generic alcohol at the top. I have an alkali group over here on the left, and I have an OH group on the right, which is called a hydroxyl group. Let's take a look at the classification of our alcohol. So I have a carbon bonded to an OH and a carbon, and that carbon is bonded to another carbon in this alkali group here, and that's said to be a primary alcohol. This carbon in the middle is bonded to 2 carbons in these 2 alkali groups. So therefore, the second molecular structure is a secondary alcohol. Now, all the way over to our right is bonded to 3 other carbons. So therefore, it is said to be a tertiary alcohol. So now that we have an understanding of the basics, we are going to take a look at nomenclature of alcohols. We will start with a simple molecule, and by using the IUPAC nomenclature, I want to number my carbon chain to give the OH the lowest number possible. And in the sample problem, I have labeled the first carbon chain blue, the second one is green, and the third one follows. Now, if the OH wasn't there, then we'd have to just have a 3-carbon alkaline, which we would call propane. However, since we have the OH there, this is actually an alcohol. Therefore, alcohol is going to have an OL ending. So this is called propanol. So how would we classify this alcohol? Well, the carbon on the right here is bonding to the OH. That carbon is bonding to one another right there. So this would be a primary alcohol. So 1-propanol is a primary alcohol in terms of its classification. Now that we have an understanding of the terminology and the classifications of amines, we are going to walk through a sample problem. So you can see that there is a molecular structure, and we always want to look at our longest carbon chain. And our longest carbon chain has 7 carbons. You can see that I've numbered it from the left side, number 1, going to number 7, which is all the way on our right side. So again, you always want to number it closer to the functional group. So additionally, the functional group is on the 2nd carbon. So we have 7 carbons, which means we would use the prefix hept, so it would be heptane. And since our functional group is amine in this situation, it has a higher priority than the fact that this is an alkaline. So this will actually define the suffix. So the highlighted box in green displays the 2nd carbon, the carbon we have in our amine group. So it would be heptane 2-amine. Thank you for watching this tutorial on primary, secondary, and tertiary alcohols and amines.